Hi friends, in our last session we have seen materials used for slideways and even applications and profiles of slideways. In today's session we will see some more important materials for a slideways. Along with that, clearance adjustment of slideways, that is what are the different methods to adjust clearance of slideways. This is Faizan Kakbi and I welcome you all for lecture series of machine tool design. So let's begin. Now, as you can see on your screen, in our last session, we have seen a gray cast iron which we were using as a material for a bed. But we know that gray cast iron was quite cheaper and it has a limitation of a high wear resistance. So basically, beds were made of a gray cast iron, but we cannot make slideways by making use of a gray cast iron because of a high wear. Okay, so if high wear takes place, then obviously our slideways surface will be worn out, right? For that we need to use some other material. Okay, so the wear resistance of a spheroidal cast iron. So we are going to use a spheroidal cast iron for our slideways. Okay, why? So it provides a better, we would say, wear resistance compared to the ordinary gray cast iron. However, spheroidal cast iron is much more expensive and economically not feasible for casting the complete bed. Okay, so usually bed are made from a gray cast iron and slideways are made from a spheroidal cast iron. Okay, and both are combined, that is joined together, which means we can say that even in an integral construction, often only the slideway is a cast from a spheroidal cast iron and connected to the gray iron bed through the intermediate sections. The shapes of intermediate connecting sections is governed mainly by bed profile and to a large extent determines the slideway stiffness, that is slideway's resistance to deformation. The wear resistance of a cast iron slideways can be further improved by applying a hard coating. Okay, which means we can increase the resistance by hard coating. For instance, chrome plating of a slideways with a 25 to 50 micron layer is provided and providing a hardness of 70 and considerably increases the life of our slideways. Okay, that is you have to remember the thickness of a layer of a chrome plating that is of 25 to 50 micron. Okay, and how much hardness it is going to provide? So 70. Okay, we know even a Brinell hardness test, right? BHN, it is denoted in that. Okay, the deposition of a molybdenum coating can be improved the wear resistance of a cast iron slideways by up to 4 to 5 times. So even we can apply molybdenum coating on our slideways surface to improve its hardness. Okay, that is wear resistance. Now we are going to see the construction of a bed and a slideways and how they are attached. Okay, so there could also be a steel slideways. We can also make slideways from a steel. Okay, but these are manufactured separately and then later attached to the bed. So we can say that if a bed is welded steel structure, the slideways is also welded to it. But if the slideways have to be attached to the gray cast iron, then they are screwed to it. Okay, so we can understand this by seeing the figure. I have shown a figure over here in the next slide. Over here, you can clearly see that this is our slideway portion. This is shown by the hatching, and this portion is our bed portion. So you can clearly see the bed and a slideways are both attached by welding. Over here, you can see welding is done on a bottom side. Over here, also welding is done on a top side. Also, there is a welding provided. Similarly, there is a second type in which we have used a welded structure. This is our slideway portion. Okay, so this is a V slideway. Okay, and this is a bed. So welding is done in both these cases. Okay, so this is what it is said that steel slideways is welded with a steel bed structure. Okay, now in a second case, the screw must be ground flush with the slideway surface. To ensure a uniform deformation of a slideway surface, the fastening screw should show space that they satisfy the following conditions. So the condition is T less than or equal to 2h, where T is a distance between adjacent screw and h is the height of our slideways. So you can see in a second case, that is B, which is a mechanically coupled structure, in which you can see this is our bed structure, okay, and this is our slideway. Similarly, this is a bed structure and this is our slideway structure, in which you can see that it is done by means of a screwed, right? It is screwed from a bottom side and attached, that is both bed and slideways are attached. Over here also nut and bolt assembly is used to attach both of them. Okay, now next we can say that from a various non-ferrous materials such as bronze and alloy of zinc, which also provides a good wear resistance. They are however very expensive and we can use them only in a heavy duty machine tools. Okay, also there is a material that is plastic which can be used for preparing a slideways. Okay, so again its application is increases in a heavy duty machine tools such as boring machines, milling machines, vertical turret lathes and large planing machines. Now what are the advantages? Why we can use this? So we can say it provides ease of manufacture. Second, less friction is provided by plastic. And third, good anti-scoring and anti-corrosive property is provided by plastic. So it is very obvious that corrosion is not going to take place in case of a plastic, and manufacturing will also be quite easier. But along with that, there are also certain disadvantages of using plastic as a slideway material. So what are that? So first you can see on your screen, it is a poor contact rigidity. The coefficient of contact compliance of a cast iron pair is 6 to 8 times greater than that of a cast iron pair. Okay. Second is poor structural stiffness due to lower modulus of elasticity. Third, poor wear resistance when contaminated by the abrasive dirt. Obvious point. Fourth, low coefficient of thermal conductivity which results in overheating. And fifth, tendency to swell by absorbing the lubricant. So these are all the restrictions which are given by plastic if we use this as slideway material. Okay. Now let us proceed further. We need to see methods of adjusting clearance in slideways. Now, how we can adjust that? So we can say the life and a smooth functioning of a slideway significantly depends upon clearance between the sliding surface. Okay, the clearance can be considered optimum if it is neither too small to rise the excessive frictional force nor too large to adversely affect the uniformity of travel. Now it is extremely difficult to achieve the optimum clearance between the mating surface even with the best manufacturing technology. Okay. Moreover, we can say the initial clearance alters in the course of slideway operations due to its wear. So it is therefore necessary to provide devices for a periodical adjustment of a clearance in a slideway. So you can see the list is provided. The devices that are commonly used for adjustment of a clearance are: first, flat strips that are not clamped after clearance adjustment. Second, flat strips that are clamped after clearance adjustment. And third, taper gibs are used. So diagrams of all the three cases we are going to see. So as stated earlier, V slideways are self-adjusting and generally do not require any clearance adjustment device. However, such devices are the integral part of a design of flat and dowel slideways, which means we can clearly say that these devices, flat strips that are not clamped after clearance, then flat strips that are clamped after clearance, and taper gibs are mostly used in which type of slideways? So usually in a flat slideways and dotted slideways. Now it is evident that the dotted slideway locates the guided part. We have seen in our last session, okay, dotted slideways and open and closed type slideways, right? In that flat, circular, okay, all types we have discussed. So we can say that in dotted case, both in horizontal and vertical direction. So therefore, clearance in both the directions can be adjusted by a single taper gib or a flat strips, which we are going to see in a diagram. On the contrary, in a flat slideways, the location of a guided part in the horizontal and vertical direction are independent of each other. Hence, separate devices are required for adjusting clearance in horizontal and vertical directions. So we are going to see the diagram now. As you can see in this figure, which is showing a clearance adjustment by making use of a taper Gibbs. So first case is of a dowel slideway, second is of a flat slideways. Now in a dowel slideway, you can see this is a portion of our slideway. Okay, this is our slideway portion, and these are and these are part which is sliding on a slideway. Okay, now over here you can see a give is provided. So if we see by cutting this, so it is going to look in this way: a taper shaped give which is whose area is gradually decreasing. A taper give is provided to adjust the clearance between the matting surfaces. Okay, similarly you can see in this flat guideways. So in this flat slideways, this is our surface of a slideway, and this over over that you can see shown by the different hatching lines is a sliding element, that is a matting surface. So the adjustment over here is done in this way. You can see cutting is shown, and this portion where you can see a hatching lines is shown. Clearance adjustment by using a taper give. Now, figure 4.6, that is our downward figure, is going to depict the adjustment in a flat and dotted slideways respectively by making use of a flat strips. So over here we have used a flat strips. You can see over here one is placed in a horizontal, second is in a vertical direction, and nut and bolt are used to tighten both of them. Right. So these strips are pressed against the matting surface by means of a tightened screw. So these two screws you can see, from one on this side and another on this side on in a flat slideway, are the tightened screw, and the uniformity of the pressing force specifically depends upon degree of tightening of each screw and requires a considerable skill and experience on the part of operator. The device has low rigidity, and this coupled with a lack of uniformity of a pressing force prevents its application in heavy loaded and high accuracy machine tools. The second is an example of a dowel in which again you can see a vertical flat strip is used, and it is tightened by making use of a tightening screw in a horizontal direction. You can see this screw, right? So this is an example of a clearance adjustment by a flat strips. Okay, now let's move. The stiffness of a slideways using a flat strip may be improved by clamping the strip after clearance has been adjusted. The arrangement of a flat and dotted slideway you can see in this diagram. Okay, so first diagram A is of a flat slideway, second one is of a dotted slideway. Over here again we can say a stiffness of a slideway has been adjusted. Over here we can say stiffness has been improved by using a flat strips. Over here you can see, and by clamping the strips after clearance has been adjusted. So again a nut and bolt arrangement is used for tightening this arrangement between the matting surface. Similarly is in a case of a dowel slideways. Over here from a bottom side two vertical screws are used. One is in a vertical form arranging the flat strips with the matting surface, and another one is in a horizontal direction. So tightening is done in this way. Okay, now let us move further. Now next we need to see a taper give, methods of tightening the taper give. So the taper give is slightly more expensive but combines the advantage of both good stiffness and uniform pressure distribution. Taper gives have a taper in a range of 1:40 to 1:100. The taper angle on a longer gives is small and vice versa. The tightening of a taper gives requires a great caution, as over tightening can lead to a considerable lateral loading resulting in a large pressures and a fast wear of a slide. The method of tightening taper gives, which you can see in this diagram, has been shown. The clearance adjustment device using a taper gives for a dowel and a flat slideways have been shown. Now it is more often the adjusting screws for tightening the taper gives are placed at both the ends to provide a finer adjustment. If the taper give is longer, it can result in excessive weakening of a guided part at the thick end of a taper. So over here you can see this diagram. Okay, so this represents the method of how to tighten the taper gives, and the example which we have seen in our previous case, that is over here you can clearly see that how we are going to make use of a taper gives for tightening, right? That is a clearance adjustment of this slide base by means of a taper give. Now how to tighten that is shown in this diagram. So you can see there are three different methods. In this question you have to mention the three different techniques along with the diagram. In that, first you have to show a flat strips which are not clamped after clearance adjustment. Second, flat strips that are clamped after clearance adjustment. And third, taper gives, that how we are using a taper gives for clearance adjustment and how we can tighten this taper gives. So diagrams has to be drawn. Okay, so in today's session we are keeping up till here. In next session we will continue with our next topic of this chapter. So till then, stay tuned and thank you all.